हरिः कर्ता।
Now it's time to deep dive into the various interpretations of the probability. There are main three types of probability. Initially, we have discussed many, around seven. So now, out of them, our focal area are classical probability, empirical probability, subjective probability. So first we will look into the classical probability. We will do some examples, and after that empirical, then subjective. Then we will get into the addition law of probability, multiplication law of probability, then conditional probability, Bayesian probability, law of total probability, and then after that we'll get into the distributions. Okay, so now for now let's begin with the classical probability. So classical probability, so before we understand what is classical probability in detail, we will see the history of classical probability, from where it came, and who brought the classical probability and everything. Okay, let me write down. So classical probability theory, also known as Laplacian theory. This is also known as Laplacian probability. Laplacian probability theory was developed by French mathematician Pierre-Simon Laplace in the 18th century. Laplace sought to provide a mathematical basis for probability theory, so which had previously been studied primarily in a philosophical context. So Laplace's approach was based on the assumption of equally likely outcomes in a sample space, and he used combinatorial methods to calculate probabilities. He also introduced the concept of conditional probability, which is the probability of an event given some other event has already occurred. Let me put it here. So Laplacian probability based up no named after Laplace, and he brought up that equally likely events, and then he also got the conditional probability, very important, very important conditional probability. So which is the what is conditional probability, just for your reference for later stage. So conditional probability is the probability of an event given some other event has already occurred. Okay, that's what the conditional probability is. So Laplace work in probability theory was influenced by his work in celestial mechanics, where he used probability theory to make predictions about the motions of celestial bodies. So he also applied probability theory to the other areas such as social sciences, economics, and biology. So classical probability theory has since been extended and generalized to include other types of probability, such as Bayesian probability. That's a completely new thing. Classical probability, and in addition to that, what we have is a Bayesian, but it was intermixed. Okay, intermixed with the Bayesian probability uh, and frequency probability. So, however, Laplace's work laid the foundation for modern probability theory and its applications in a wide range of fields. So, now we know the classical probability history. Now, what is a classical probability? So, classical probability uses sample spaces to determine the numerical probability that an event will happen, and assumes that all outcomes in the sample space are equally likely to occur. Very important. equally likely to occur. So that's why, as per the classical probability, probability of an event occurring is equals to number of desired outcomes divided by total number of possible outcomes. So number of desired outcomes divided by samples divided by sample space size. That's what is the classical probability. Then empirical probability and or your frequency probability varies. That what is that, we'll see later. What is the empirical probability, we'll see in soon. But at this moment for you, the classical probability should be damn clear. So classical probability uses sample spaces to determine the numerical probability that an event will happen, and assumes that all outcomes in the sample are equally likely, there is no bias, okay, equally likely to occur. And the probability of event E occurring is equal to number of desired outcomes of event E divided by total number of possible outcomes. That's the sample size, that sample space size. Okay. So rounding rules for probabilities. Probabilities should be expressed as reduced fractions, or rounded to two or three decimal places. When the probability of an event is an extremely small decimal, it's permissible to round the decimal to the first non-zero digit after the decimal point. I'm repeating that. This is the rounding rule for the probability. There is a rounding rule. If you have a huge number of decimal points, you can't keep that. You have to round it off. Probabilities should be expressed as a reduced fractions, are rounded to two or three decimals. It should be rounded to two or three decimal places. Okay, two or three decimal places. That's what is a classical probability.